Hello, hello to all. Today we are going to discuss about starters. In our homes, in our domestic applications, we might have seen that while switching on of motors, due to the initial inrush current taken by the motor, all the electrical appliances connected will just dim and again it will glow. The reason for that is at the time of starting a motor, the current consumed by the motor will be very high. Since the current consumed by the motor is high, it takes a transient condition and all the electrical appliances connected to the system will get affected due to this. For that, we need to go for starters. Starters can be used for DC motors as well as induction motors. In today's session, we shall see about starters used for DC motors. According to the principle of working of a motor, in a DC motor, we have the principle of working of a motor is when a current carrying conductor is placed inside a magnetic field, it experiences a force and it starts to rotate. Here, for the magnetic field, we are having a permanent magnet, and for the current carrying conductor, we are having a armature winding. When this current carrying conductor is placed inside a magnetic field, this will experience a force and it will start to rotate. This is the principle of working of a motor. This is for a small motor where we use a permanent magnet and the armature winding is a copper conductor. Whereas for larger rating motors, we prefer to go for electromagnetic coil, which is the field winding. The field winding is made up of electromagnetic coil, which is number of turns of wire is bound and supply is given to the coil. This will produce magnetic flux. As this produces magnetic flux, this is the armature winding, and when the armature winding cuts the magnetic flux, and this will act as a current carrying conductor. When current carrying conductor cuts the magnetic flux, it will rotate. A rotating torque will be created and your rotor will start to rotate. Now, we shall see the necessity of starter. Based upon the connection of this electromagnetic coil with the armature winding, the winding on the rotating part is called as the armature winding, and the winding which is being wound for the producing the magnetic flux is called as the field winding. Suppose if the field winding and the armature winding are connected in parallel together, then it is called as shunt motor. In a shunt motor, the armature winding current is taken as IA. The current flowing through the armature winding is taken as IA equal to V minus EB by RA. That means your armature current is based upon the supply voltage, the resistance of the armature, and another important term is with respect to back EMF. Back EMF in a DC motor is when your armature conductor rotates inside a magnetic field. When armature conductor rotates inside a magnetic field, as per Faraday's law of electromagnetic induction, whenever a conductor cuts a magnetic field, even though it is the working principle of a motor, as when the conductor rotates inside a magnetic field, as per Faraday's law, whenever a conductor cuts a magnetic field, an EMF will be induced in the conductor. That means when your armature conductor is rotating due to motoring action, in the armature conductor, a voltage is being induced in the armature winding. That induced voltage in the armature winding is called as back EMF because it will act in opposite direction to the applied voltage. The back EMF will work in opposite direction to the applied voltage. That means the armature current taken by a motor IA is equal to V minus EB by RA, where EB is given by phi is a NP by 60A. In this, Z is number of conductors, P is number of poles, A is number of parallel paths. That means EB can be written as proportionate to phi and N. That means if N varies or flux varies, back EMF will vary. Flux is produced by the electromagnetic coil, that is constant. Speed at the time of starting is 0. If speed is 0, back EMF is 0. If back EMF is 0, as per this equation, if back EMF is 0, suppose if we are applying 220 volt that means 220 minus 0, and the resistance of the armature winding is Ra is equal to, we will have a resistance normal for a small 3 HP motor, we will have Ra value equal to 3, that means it is 3, that means Ia value equal to 220 minus 0 by 3. That means our current will be 220 by 3, it is around 73.3 amps. A normal 3 HP motor can withstand only 12 amps of current, whereas if 73 amps of current flows through my armature winding, then the windings will get damaged. And due to this, we will have a lot of problems with other systems, electrical systems connected to this motor. In order to avoid this, we need to go for a starter for a DC motor. According to the principle of working of a starter, in series with the armature winding, in order to reduce the starting current, we need to add a resistance in series with the armature. By adding a resistance in series with the armature, now say for example, we'll use the same relation, Ia equal to V minus Eb by Ra. Now V is 220, back EMF is 0 at the time of starting, and we are having a 3 ohm resistance in the armature. Now we have added another starting resistance in series with the armature. That means, say for example, I am adding a 50 ohm resistance. If you add a 50 ohm resistance, it is 220 by 53, because this starting resistance is connected in series with the armature. It is Ra plus RST, starting resistance. Now your current will be approximately 4.15 amps. That means our current has got reduced from 73 amps to 4 amps. That means by varying this resistance, it is possible for us to control the current in a DC motor. It is very important in a DC motor, the starting current is reduced, as well as the required torque is also maintained in a DC motor. The required torque is proportionate to, in a DC motor, torque is proportionate to 5 into Ia. That means we cannot reduce the current to a larger extent, as well as the current has to be maintained within the safer limits. For this, what we do is, in order to have a gradual variation in the armature current, instead of going for a fixed resistance like this, we prefer to go for a variable resistance, as in the case of a 3-point starter, where we will have variable resistance stages like this. In this, we are having a model of a 3-point starter. In a 3-point starter, as shown in the circuit, it has variable resistances. Multiple resistance stages is being connected. These are the resistance stages, and this resistance is connected to the copper stud. And when we move the handle from stud number 1 to the last stud, when we move from one stud to the next stud, the resistance will be disconnected one by one. That means at starting we will have full resistance, and when we move from one stud to the next stud, the resistance value keep on decreasing. And when I move to the final stud, my entire resistance will be disconnected from the circuit. For this, we use a 3-point starter. In this, it is only not only for limiting the starting current, but we have some protective devices also. We have a low volt relay and an overload relay. The purpose of low volt relay is, this low volt relay is electromagnetic coil. When I give supply to this electromagnetic coil, it will get magnetized and hold this handle in on position. It will get magnetized and it will attract and keep this handle in on position. If power goes off, immediately the handle gets released and returns back to the home position. This is the purpose of low volt relay. That means every time we switch off and switch on the motor, we start with the resistance only. The next protected device is overload relay. This is connected in series with the armature. From your line, it is connected in series with the armature. When overload occurs, the magnetic field produced by this overload relay will be higher. The magnetic strength will attract this lever to the top position. That means this lever will get attracted like this when the magnetic field strength is 4. These two leads will get shorted with each other. These two leads are placed in parallel with the low volt relay. That means when the low volt relay is being shorted, then automatically the handle gets released and comes back to the home position. That means even if under overload condition, the motor will get tripped automatically. That is the purpose of going for 3-point starter. Thank you.